Hello viewers, in today's session we are going to find out the value of this definite integral. So here we have to evaluate the integral from minus 10 to 10. We have cot inverse x dx, right? So here let us first call this integral as I. Now here we can use two methods to find out the value of this integral, but here we'll discuss only the first method, right? So in the first method, we'll make use of the method of substitution. So let us make this substitution, that is x is equal to minus t, right? So the purpose of making this substitution is to make use of this uh, identity, that is cot inverse minus x is given by pi minus cot inverse of x, where x belongs to the set of real numbers, right? So we'll take x is equal to minus t, so that dx over dt is equal to d by dt of minus t. So this is minus 1, so we can write dx is equal to minus dt. So let us change the limits accordingly. So when the lower limit is minus 10, then the corresponding value of t is given by substituting x is equal to minus 10 in this expression. So we have minus 10 is equal to minus t, so t is equal to 10. And when the upper limit is plus 10, then the corresponding value of t is given by 10 is equal to minus t, so t is minus 10. So when x varies from minus 10 to 10, t varies from 10 to minus 10. So let us now write this integral I in terms of t. So we have here 10 to minus 10, and cot inverse of x is minus t, and for dx we can now write here minus dt. So now let us simplify this integral using this property of definite integrals, that is a to b, and f of t dt is equal to negative of b to a f of t dt. So when we interchange the limits, the value of the definite integral is negative, right? So here we can neutralize this negative sign by interchanging the limits. So we can now write minus 10 to 10, and we have cot inverse of minus t and dt, right? So we can now write minus 10 to 10, and cot inverse minus t can be replaced by this expression, that is if we apply this identity to cot inverse minus t, then we can write pi minus cot inverse t, and here we have dt. So let us write this expression as minus 10 to 10, we have pi dt, and then we have minus 10 to 10 and cot inverse t dt, right? So now we have I, and we have now two integrals. So here we can take pi outside the integral, and we have minus 10 to 10 dt, and this integral is now equal to I, because here we can again make use of one important property of definite integrals, which says that the integral a to b f of t dt is equal to integral a to b f of x dx. So this is the dummy variable property. If we replace the variable t by x, then the value of both the definite integrals remains the same. So here this integral can now be written as I. So now taking this minus I to the left hand side, we have I plus I, and here we have pi. The integral dt is simply t. So here we have t, and limits are from minus 10 to 10. I plus I is 2i, and here we have pi, and substituting the limits and taking the difference, we have this expression. So now we can write 2y, and we have pi and 10 plus 10. So this is 2y is equal to pi times 20. So I is 20 pi over 2, that is 10 pi, right? So the value of this integral I is equal to 10 pi. Now here it is interesting to note that the value of this definite integral can also be obtained by using this identity, that is cot inverse x plus tan inverse x is equal to pi by 2 for all x belonging to the set of real numbers. So we can replace cot inverse x by pi by 2 minus tan inverse x, right? And then applying the property of definite integrals, that is for odd functions, that is minus a to a, f of x dx is equal to 0 if f of x is an odd function, right? So using these concepts, we can also arrive at the value of this integral as 10 pi. Hello viewers, in today's session we are going to discuss an important problem from definite integrals, and here we have this problem. We are given two functions f of x and g of x such that f prime of x is equal to g of x, and f of 4 is equal to 2, and f of 1 is equal to 3. And then we have to find the value of this integral, that is integral from 1 to 4, and here we have the square of f of x and g of x dx, right? So let us see how we can easily find out the value of this integral using these conditions along with the method of substitution. So let us start. So here we are given f prime of x is equal to g of x. So let us write this expression as d by dx of f of x, that is equal to g of x, and let us take this integral as I, right? So now here what we will do, will assume t is equal to f of x, right? So when t is equal to f of x, then this expression can be written as d by dx of t is equal to g of x, right? So that dt is equal to g of x dx, right? And this integral can now be written in terms of t, and let us first change the limits. So here the limits of integration vary from 1 to 4. So when x is equal to 1, then the value of t can be obtained from this expression. So t is equal to f of 1, and f of 1 is given as 3, right? And when x is equal to 4, which is the upper limit, then the value of t can be written as f of 4, and f of 4 is given as 2, right? So now this integral can be written in terms of t, that is here t varies from 3 to 2, because when x goes from 1 to 4, t goes from 3 to 2. And for f of x we can write t, so here we have t square, and for g of x dx we can write dt. So now we have a simple integral here. So the integral of t square dt is simply t cube over 3, and the limits of integration are from 3 to 2. So now substituting the limits and taking the difference, we have 2 cube over 3, and then we have 3 cube over 3. So 2 cube is 8. So we have 8 over 3, and here 3 cube is 27 over 3. So this is 8 minus 27 over 3, that is minus 19. 8 minus 27 is minus 19. So this is minus 19 over 3. So the required value of this integral I under these conditions is equal to minus 19 over 3. Hello viewers, in today's session we are going to evaluate this definite integral. So here we have to evaluate the integral that is from minus 1 over 4 to 1 over 4, and here we have cos inverse x dx. So let us take this integral as I. Right, so here we'll solve this integral with the help of one important identity or result from inverse trigonometric function connecting sine inverse x and cosine inverse x, right? And then we'll make use of one important property of definite integrals. So let us start. So now from inverse trigonometric functions, we know that sine inverse x plus cos inverse x is equal to pi by 2, where x belongs to the interval that is minus 1 to 1, right? So here we'll express cos inverse x in terms of sine inverse x. So we have cos inverse x is equal to pi by 2 minus sine inverse x. So let us now write the integral I as minus 1 over 4 to 1 over 4, and here we have pi by 2 minus sine inverse x dx. So now let us write this integral as a difference of two integrals. So we have minus 1 over 4 to 1 over 4. We have pi by 2 dx, and then we have the integral that is here minus 1 over 4 to 1 over 4 sine inverse x dx, right? So now this integral is easy to evaluate. So we can now write pi by 2, then we have minus 1 by 4 to 1 by 4 and dx. Now let us see this integral. So here the value of this integral is 0, because we know an important property of definite integrals. So we have this property that is minus a to a f of x dx is equal to 0 whenever f of x is an odd function, right? And if we compare this integral with this one, then the value of a is equal to 1 over 4, and f of x is equal to sine inverse x. Now if we replace x by minus x, then f of minus x is equal to sine inverse minus x. And from inverse trigonometric functions, we know that sine inverse minus x is minus sine inverse x, right? So sine inverse minus theta is equal to minus sine inverse theta. So sine inverse x is f of x. So we have minus f of x, right? So sine inverse x is an odd function, because a function f of x is said to be an odd function if f of minus x is equal to minus f of x, right? So the value of this integral, that is minus 1 over 4 to 1 over 4 sine inverse x dx, is equal to 0 due to this property, right? And here f of x is an odd function, and in case of even function, the value of this integral is given as 2 times 0 to a and f of x dx, provided f of x is an even function, that is f of minus x is equal to positive f of x. So the value of this integral is 0. So now we have pi by 2, and here the integral dx is simply x, and limits are from minus 1 over 4 to 1 over 4. So we have pi by 2, and substituting the limits, we have 1 over 4, then we have minus 1 over 4. So this is pi by 2, 1 over 4 plus 1 over 4. So the value of I is pi by 2, 1 over 4 plus 1 over 4 is 2 over 4. So 2 and 2 get cancelled. So we are left with pi by 4. So the value of this integral I is equal to pi by 4.